Welcome to Study Loop.
So this question asks us to solve a few Lewis structures. So we'll start with the pH4+. So we'll begin by looking at our valence shell electrons. So phosphorus will have 5 valence electrons to start, and there's only one of them, so we have 5. Hydrogen will have 1 electron each, but we have 4 of them, so 4 hydrogen will give us 4 electrons total. We can add these up now, except we also have a charge, and since it's a positive charge, we'll be losing an electron, since electrons are negatively charged. So our 5 plus 4 minus 1 gives us 8 total valence electrons in this molecule. So to start, we'll draw our central atom of phosphorus and draw a bond to each of our surrounding atoms of hydrogen. There's 4 of them, so we have 4 bonds. So those 4 bonds are going to be 2 electrons each, which means our 2 electrons times 4. We have used 8 electrons already, meaning we are set on our valency. We can see that our phosphorus has a full octet, and hydrogen has 2 electrons attached to each, which is good because they break the octet rule. They're an exception and only want 2 electrons. We still have to place the charge, though. So the charge can't go on the hydrogen because they don't have any other orbitals to have it be occupied. They're completely full and happy. We wouldn't know which one to put it on anyway. So it will probably be localized on our central atom of phosphorus. This is our Lewis structure of pH4+. So the next system they want us to solve is C2F4. So we'll start with our carbon, which has 4 valence electrons. And we have 2 of them, so 2 carbon will give us 8 valence electrons. Next, our fluorine will have 7 valence electrons each, and we have 4 of them, so we have 28 valence electrons total. We'll add those up, and there's no charge here, so it's just our 8 plus 28 electrons is going to give us 36 total electrons. So to start drawing our structure, we'll draw what will probably be our central atoms of the 2 carbons with a bond between them. And then we'll symmetrically draw our fluorines to start. So we have 2 fluorine on each carbon with the bond between them. Now since fluorine are halogens, they only really want one bond between them, so we'll go ahead and throw lone pairs in to fill up the rest of their individual octets. So that's 3 lone pairs on each. And let's count up how many electrons we've used. So we have 5 bonds total. 5 bonds will be 2 electrons times 5 is 10 electrons total. We've also used 3 lone pairs times our 2 electrons per lone pair, and we've used that 4 times on each fluorine, so we'll multiply that by 4 as well, and that'll give us a total of 6 times 4 is 24 electrons in our lone pairs. So total, we've used 10 plus 24 is 34 electrons. We're missing 2. Each of our carbons is also not full. We can see they only have 6 electrons attached to each, so we know we need to add more there to fill their octets. However, we only have 2 electrons left with our 36 minus 34, so we know we have to put a second bond in between them. And that fills up the octet and adds our last 2 electrons. So we can see we've used all 36. So this must be our Lewis structure for C2F4. So the last Lewis structure we have is SbH3. SbH3. So we'll start with our valence electrons. So our Sb, our antimony, is going to have 5 valence electrons, and there's only one of them. Our hydrogen will have 1 electron each, but we have 3 hydrogen, so there will be 3 electrons total. So our system overall, since we have no charge, is our 5 electrons plus 3 electrons. We'll have 8 total valence electrons. So we'll start by drawing our central atom with the antimony and draw our outlying atoms with 1 bond each. We know that hydrogen is full already from its exception to the octet rule. It has 2 electrons in the bond, so we've used 3 bonds, meaning we've used 3 times 2 electrons. We've used 6 electrons so far. So we have 2 left. We'll go ahead and throw that as a lone pair on the antimony to fill its octet. So now it has 8 electrons total. We've added 2 to our 6 electrons, gotten 8 electrons, which is where we started. So we know that this is our Lewis structure for SbH3.